One trend we've seen a lot in programming in recent years is the attempt to replace C. And I think that's both wise and terrifying. It's wise because C is about 50 years old. And being old doesn't make it bad, but it has given us 5 decades to think about what works and what doesn't work in programming language design. We've got 50 years worth of techniques we really ought to be putting into practice. And putting them into practice is the terrifying part, because C is everywhere. You may not write C, but I guarantee you're writing something that runs on something that runs C and was written in C. It's in the compilation stack for everything we install. So if languages like Go and Rust want to become the new C, they've really got their work cut out for them. All of which makes this week's topic kind of breathtaking. We're looking at Zig. It's a language that's not only trying to take on C and C++ and Rust and Go for that systems programming crown, it's also trying to replace the infrastructure that C itself gets built on, things like LLVM. So it can hopefully become the best way to build systems-level software across all different architectures. Zig ends up being a project with a huge scope. And if you're a fan of programming languages, there is a lot to chew on this week. We cover cross-platform compilation to memory management techniques to new thoughts in compile-time metaprogramming. As well as when you've got these huge long-term ambitions, how do you structure an open-source project for long-term funding? There is a lot of ground to cover, so this is a bit of a longer episode than usual, and we'd best get started. I'm your host, Chris Jenkins. This is Developer Voices, and today's voice is Loris Cro. I'm joined today by Loris Cro. How are you doing out there, Loris?
Hello. Hi, Chris. Pretty good. Thank you.
Good. It's good to have you here. I always love it when we do a language deep dive because I'm a particular fan of the world's programming languages. And you're going to tell us all about Zig, which is a language I don't think I'd heard of until we had Joran Dirk Grief on the show from Tiger Beetle, who said they've written a new database in Zig. And I thought, well, we have to do something about Zig. I have to learn about that. So let's start here. I always think new programming languages come into being as a reaction to what's missing in the marketplace, if you like. Like, there's a burning reason why Zig needed to exist. Do you think that's true? What's Zig's raison d'etre?
Right. So I guess a way of answering this question, like factually, is maybe to look at how it was created originally. So the original creator, Andrew Kelly, wanted to make a digital audio workstation software.
Yeah. For making electronic music and that kind of thing.
Exactly.
Yeah.
And he tried a bunch of different languages, and he was unhappy with all the solutions, with all the trade-offs that each offered. So I think he started with higher level languages and then quickly found out that to do real-time audio processing, you can't use a language with like automated memory management and like languages that don't give you precise control over the hardware.
Yeah, because audio is one of those places where we're talking hard real time.
Exactly.
Yeah.
You have to be there on time.
Yeah.
Yeah. And but on the other end of the spectrum, at the time, the main languages that did give you full control over the machine were like C and C++, and each had its own, like, if you will, baggage of issues, which some of it is also up to like personal taste. But for example, C is very low level, but it doesn't have good metaprogramming facilities. C macros are very well known for being not particularly good.
Yeah.
Yeah.
Yeah, they're not much better than string munging, right?
Yeah, exactly. No. You mess around with strings and you have a lot of like unwanted side effects, oftentimes. So it's a food gun. That's how we usually think of it.
Yeah.
On the other hand, you have C++, which I don't know if he actually did attempt to use, but in general, C++ exists in a space where the language is very powerful, it's very complex, and it's a type of language where you are heavy with abstractions oftentimes, and that kind of detracts from what you're trying to accomplish. Or rather, some people can definitely make it work for them, and that is their preferred way of programming, so that's good. But for some other people, C++ doesn't really, it doesn't feel good in your hand as a tool for some people.
I can see how people... We're not going to start a language war, but you can certainly see how people would feel that way about C++. We can say that.
And to me, this is not really a thing of language war at all. Like, I can fully appreciate how somebody who likes that way of doing things can make it work for them. But on the other hand, like for me personally, that way of doing things doesn't really click. So ultimately, I can totally see how somebody would be productive with C++. And I wouldn't. So I need a different tool.
Right.
And I think that Andrew also shares, generally speaking, this perspective. So he wanted to make a language that was low level, so that gave you full control over the machine, that would be suitable for an audio workstation. And that, on the other hand, it wouldn't be overly complicated. And there's like a sentence that you can find in like Zig's on the website, where we say it's one of the first things that you can see on the front page. It says, focus on debugging your application rather than debugging your programming language knowledge.
Right.
Yeah.
Yeah. Okay. So that's kind of... I know people, anytime you write something that's sort of competing with C in the low-level world, someone says, well, why not Go and why not Rust? But you begin to demarcate those as... I'll let you answer it. Why is it not Go or Rust?
So the reason why it's not Rust, I would say, is like the answer is in a very general way, it's kind of the same answer as why not C++. I think that Rust is another language that likes its own complexity, and it gains a ton of power from that, for sure. But the complexity is there, and also when it comes to like giving you full control over the machine, Rust, it's not entirely of that opinion. Like Rust, for good reasons, for safety reasons, Rust wants to relegate certain things inside unsafe Rust, which is a part of Rust that you are not supposed to use lightly. So that means that you will find out there libraries that when choosing between maximum performance and safety, they will choose safety probably over performance oftentimes, because you do get audited if you have unsafe or not. So in general, Rust is going for something slightly different than what Zig is going for.
Okay.
So both in terms of like trade-offs between performance and safety, but also in terms of abstraction. And I would argue also like readability in terms of like the complexity, because writing abstracted code makes it harder to understand and to read for a consumer. When it comes to Go, I think that Go and Zig both share an appreciation for simplicity, although Go is not just simple, it's also very minimalistic. So I would say that there are like some parallels between Zig and Go, but we don't have the exact same take on everything. And I can get more into detail if you want later. But ultimately, Go is not as low level as Rust and Zig are. I am not sure if Go would be the best choice for an audio workstation, for example, or for an operating system, because Go has a runtime, has a garbage collector. Also, interoperability with C is a bit complicated in Go because, well, first of all, any language that has a runtime, that makes interoperability with C a little bit more complicated, because you need to give information to the runtime of your language, to the garbage collector, about what's going on with memory. And so that sometimes makes things a little bit awkward. But with Go specifically, I do think that for the Go team, interoperability with C was never a priority or something that they really liked. So Go can call C functions, for example, but you cannot do the inverse easily. So you cannot make a Go function that can be easily called from C. And I think basically this is like a philosophy of the Go team. Like they basically said, no, we want to do something different. We don't want to do something, we don't want people to rely too much on, like we want to be able to consume C libraries, but we don't want to do the inverse. If you're in Goland, you use Go. I think that's kind of their philosophy there.
Yeah. It's like we want to be able to reuse existing C, but we're not intending to live in the same ecosystem quite.
Yeah, exactly. I would say that. And you can see that also in a bunch of choices that they made also with how compilation works in Go, like in terms of the compiler. And I think it's a reasonable choice. It's a choice. It makes sense. Very different from what Zig is going for.
Yeah, I don't think we need language wars because there's a huge design space to be explored, and there's plenty of land for everyone, right?
Yeah.
But okay, so that demarks what you want to be. What's Zig's answer to this set of design constraints?
I think the most interesting part about Zig answer to, like, let's say systems programming, like lower level programming in general, is to rebuild it from scratch. All these other languages that not all these other languages, but like it is common to consider kind of like C the bottom layer of abstraction of what you're building. So for example, there are programming languages that compile to C code. Yeah. I think NIM is an example of this. And Rust itself, Rust doesn't compile to C. But for example, Rust depends on the C standard library of the platform that you're targeting. So if you're writing a Linux program, like a Rust program that you want to deploy on Linux, Rust will use the libc of your Linux distribution. With Zig, the idea instead is to really, really build everything from the bottom up. And this is a big scope. This is not like for the faint of heart. It's a lot of work. But it does yield some very good results, like some very good things that you can do once you are willing to do that work. So I would say that the most interesting thing about Zig is that it really is a language that allows you to build for every target from any target. Meaning that if you want to target like not just normal computers, but also very tiny embedded devices, you can do so easily. And that's also cross-compilation because you're compiling on a Linux machine probably, which is going to be maybe x86-64, and you're targeting a very tiny ARM V8 embedded device. So you're compiling for a different architecture there. But this is also true from computer to computer. So with Zig, it's considered fundamental, the ability to build your program for macOS, Windows, Linux from any of those other OSs. So from Linux to Windows, from Windows to Mac, etc.
That's surprisingly rare.
Yeah.
But a very nice feature.
And it doesn't end here because we can do this for Zig applications. And to be fair, I think that Go can do it for Go, Rust can do it for Rust. But they cannot do it for C, while we can do it also for C and C++. So the idea is that if you have a project that has Zig code in it and also a C dependency, not only you can cross-compile the Zig part, but you can also cross-compile the C part.
Really?
Yes. And that is, I think, the huge thing. And it's so big that actually you can use Zig as your C, C++ compiler when you are trying to cross-compile a mixed project between Rust and C or a Go and C one. So, for example, Go people have been using the Zig compiler to enable, to close the circle, to enable complete cross-compilation of C Go programs. C Go is basically what you call a project that has both Go and C in it. CGO is like a component of the Go compiler. That's how they compile NLink to C code. So Go people using Go projects, they are using Zig to cross compile, and same with Rust. Even AWS is using Zig to cross compile Rust lambdas for their Lambda engines, because Rust depends on the libc of the target, and their machines running Lambda functions are running a specific version of Linux with an older libc, and you need to be able to target the correct version of the libc to make sure that everything runs smoothly.
Right.
And that's not something that normally compilers can do. And Rust itself, which doesn't concern itself with C compilation at all, certainly cannot do. So there's a package called Cargo Zig build that allows you to use Zig to basically link against the correct libc version that works on Lambda.
How on earth is that working? Are you telling me that Zig also has a C compiler built in, or?
Yeah, it does.
Huh.
It straight up does.
Crikey. So, and Andrew started out trying to build an audio workstation and ended up building a language that also includes a C compiler.
Yeah, pretty much.
That's legendary.
Yeah, and man, and this is like, and I would say we're like halfway through the journey, because we want to get even more hardcore than this. So, I mean, if you want, we can change subject. Otherwise, I can.
No,
keep
I'm
going.
fascinated. Keep going. Yeah.
Okay. So, do you remember when Apple released the M1 architecture, right? So they went from Intel to ARM. And that was big news because, well, turned out it's also pretty good CPU, like pretty good architecture. New Macs, I would say, are pretty nice from, they're powerful, they overheat less. They're nice. So when Apple released the M1, Zig was the first compiler that was able to cross-compile for M1 from another target, from another machine. So Apple, obviously, when they released, not only when they released, but also while they were developing the M1, obviously they had tooling to compile for the M1. But they never released, or rather, when everything came out, they had not released any tooling for compiling for M1 from another machine.
Oh, so you had to buy the new Mac in order to build for the new Mac.
Exactly, because what you would get was when you have macOS, you get Clang. You get a fork of LLVM, which is it's I would say it's kind of pretty much LLVM, except with like private patches that Apple makes specific to their system. And when the M1 came out, they had patches specific to the new architecture, so you could compile. Obviously, from M1 to M1. But LLVM itself, the open source project, did not support M1 yet fully. And so you could not get LLVM like on Windows or Linux and then use that to compile for macOS. We were the first ones. And that was because not only Zig is a C compiler, and to be fair, the C compiler stuff right now, I would say, at its core, it's not super impressive. The idea is that Zig uses LLVM, and LLVM is like this library that allows you to, it's like a unified framework for optimizing, for generating optimized machine code. So the idea is that your compiler reads the program that it's trying to compile, builds a data structure in memory, does semantic analysis, all the usual stuff that a language has to do. But then the final step is to give some of that information to LLVM, which will then take care of selecting which exact instructions to use for the CPU that you're targeting.
Right. So it's, I suppose, I want to say it's almost a little bit like WebAssembly. It's like a very low level language that's actually going to generate the final machine code.
Yeah,
it's possibly a bit of a stretch, but
I think that's fair. That's called the LLVM IR, intermediate representation.
Yeah,
that's what you create, which is a bit code of some kind and bytecode, of some kind of like a WebAssembly. I think that's a fair parallel.
Okay.
Yeah, so we give that to LLVM, and since we're already bundling all of LLVM, it doesn't take much to also add Clang, which is the C compiler that runs on LLVM. So that's what's allow us to build C. There's more than Zig does, but at its core, it's not super complicated. But a compiler is just one step necessary to create a final executable. There's also a linking phase at the end. So the main problem with the new M1 Max was that linking needed to be different than it was in the past. And the reason why we were the first ones to be able to cross-compile for M1 was because we had our own in-house linker. There's a core team member in the Zig project. His name is Jacob Konka, and he used to work at Microsoft, and we kind of poached him to work. Well, I guess he poached himself. He wanted to work on linkers. I think at Microsoft he was not working on anything even remotely as exciting, and so he decided to jump ship and join the Zig project full time. So we have our own linker, and most of the work is done by him. And so my point here is that by having our own linker, we were able to reach to have a feature even faster than LLVM could. And LLVM is considered in general like a very good project, and it is. And it is.
Yeah.
But the point is that we did not consider LLVM the baseline. We were willing to get past LLVM and do some of that work ourselves. And now, going forward, and this ties back to my point that we are only halfway through our journey. Now, going forward, we plan to make LLVM a completely optional component. So that means that we have our own implementation of some of what LLVM does. So we have what we call them backends. So we have our own implementation of what reads the internal representation of the compiler, the internal data structures, and decides which instructions to output. That's a lot of work because you have to build one of those things for each architecture they want to support. So you want to support x86 64, that's one implementation. ARM 32-bit, another. ARM 64-bit. x86, like 32-bit x86, that's another one. There's more architectures out there. So for each one, you have to write a specific one, and then you have to write another bit based on the OS that you're targeting. So like x86 64 Windows is a little bit different than x86 64 Mac. Not in terms of like the instructions of the program, but like the packaging, like how an executable is structured, all the like surrounding metadata, the framing in a sense.
Right, yeah.
And we're doing it. Now, the work that we're doing in that regard right now is not to replace LLVM in terms of optimizations. So the bulk of what LLVM does and what it's considered state of the art for is optimizations. We are not doing that yet. What we're doing right now is basically do the work so that we can have debug builds, which are not optimized, happen without needing LLVM at all. That's our starting point. But the plan is going forward to basically have a competing optimizing backend. So you will still be able to use LLVM if you want. How it's going to happen in practice, it doesn't matter much. I think it's going to happen that you basically will need to get LLVM through the package manager. So you will use the Zig package manager to get LLVM instead of getting it bundled in the compiler itself. But then you will be able to get an LLVM optimized final executable regardless. But we're going to work on our competing version. And you will decide which one you like more. And over time, if we do a good job, it might even be that our competing backend becomes compelling enough that people will use that one over LLVM.
Crikey, you're not kidding about going all the way down to the lowest level, right? Yeah, no. Jeez.
Yeah.
Okay, that's... What's your timeline for that?
Oof.
That's got to be a multi-year project, right?
100%. Yeah, for sure. Honestly, I don't know what the timeline is going to be. The reality is that the timeline of these things can vary dramatically depending on the amount of talent that you attract. One thing that the people usually say when we first tell them, we want to get rid of LLVM, they start by saying, oh, you're insane. You're never going to be able to do it. There's a bunch of geniuses that work on LLVM. Fair. Fine. Let's assume that that's right. I mean, I'm sure that the people working on LLVM are smart. But it's not like they are bound by a blood contract to work on LLVM. And working on LLVM, it's a humongous C++ project, takes forever to compile. And it's in some ways like it's messy. What if we were to be able to present to people working in that field another ecosystem where they can research the same exact kind of optimizations that they are researching and implementing on LLVM, but the compiler, instead of taking 4 hours to build, it takes 20 seconds.
I imagine that would be very seductive. And I think you're deliberately trying to seduce people over to the Zig side, which is fair enough.
And I mean, we already have people in the core team who have push access to LLVM. So it's not like we are like, I don't know anybody who is part of like the leadership of LLVM, so I wouldn't say we are like insiders. But we already know people who do this. So
sounds like there's a potential for both knowledge sharing and maybe some more kinds of sharing out there.
Absolutely. And if LLVM also ends up benefiting from this, it's great for everybody.
Sounds like one of those whoever wins, we all win situations.
Absolutely.
Okay. This is getting very low level. Maybe we should try and pull it back into user space. Love the ambition, though, absolutely. Yeah. But I do want to get a sense of what it's like to write Zig. What am I going to find as a programmer? What am I going to like? What am I going to need to learn?
Right. So the hardest part about Zig is not Zig at all. Zig as a language is very, very simple. The most complicated part of Zig right now is comp time, which is the ability to run code at compile time instead of runtime. And if you're not used to thinking about the two different lifetimes of your program, the two different phases of its life, then you might get a little bit confused about what it is that you can do at comp time or what it is that you cannot do at comp time. But overall, the core principle is, in my opinion, kind of straightforward. Where things get complicated is once you get into systems programming more in general. So if you're like a JavaScript or a Python developer and you never had in your life to think about stack versus heap, or maybe people told you, but like if you're a Python programmer, this is something that also happened to me like in university. If you do Python and people tell you about stack versus heap, that's like philosophy to you because that's right. You don't have control.
Fascinating, but you'll never use this knowledge.
Exactly. Like you don't have control over it. And
But when you're getting to low-level systems programs, suddenly this becomes a real concern, right?
Exactly. And so the hardest part is, for example, understanding the difference between an array of whose length you know statically. Like this is going to be a 6-element array and it's always going to be 6. Or maybe you need up to 6 slots. Maybe at some point in time you use fewer than those. So you have like a counter that tells you how many slots you're using. But 6 is the limit. So, and if you know this statically at compile time, then this can be put on the stack. And there's certain things that you can do with this memory thanks to the knowledge of the fact that it's bounded to 6 elements. And this,
you know exactly how much memory it's going to need for the whole lifetime of the program.
Exactly. And that is critical information for the compiler itself. Like the language, lower level languages are like designed around these very critical concepts of like what you know statically and what you do not know statically. So if, for example, instead you have a program where you ask the user to tell you how many items they want to enter, and they are allowed to enter 10,000 if they want, or more realistically, imagine parsing a JSON file. Like a JSON file can be arbitrarily deeply nested or big in general. So at that point, you need to concern yourself with heap allocation. which again is something that in Python and JavaScript you don't do directly because the runtime manages that for you.
Yeah.
So that's one example. Another example is things that your platform, like APIs that your OS operative system gives to you, which people sometimes are used to think about as in terms of capabilities that the language gives to them, even though the language can only act as an intermediary. So, for example, sometimes people ask, how do I get the size of the terminal window in Zig? And the answer is, well, the real question is, how does your OS allow you to get that information?
Right.
And that's going to happen through a syscall of some kind. And then I guess the secondary question is, has somebody written the boilerplate to access that syscall, and where is it in the Zig standard library? So the question of how you do this kind of stuff in Zig or in each specific language, it's not completely wrong. It does make sense. But understanding what is the actual API below you can be a little bit annoying, especially when the language wants to show you precisely what that is, and it's not trying to give you a sugared interface that is overly simplified. Because sometimes you do also get that in other languages, which might make sense. Like a higher level programming language, it makes sense that it doesn't give you necessarily low level access to everything. So I would say these are like the biggest challenges. People need to learn systems programming. They need to have this mindset where they have to think, okay, how, like when, for another example, people sometimes ask, how do I print colored text in the terminal? How do you do that in Zig? And the answer is, Zig doesn't concern itself with this. Like, these are escape codes. It depends on which terminal emulator you're using and a bunch of other related concerns that really are pretty much transparent to Zig. But people don't have this mindset. So I would say that is the hardest part about learning Zig. And connected to this, there aren't a lot of good learning materials, in my opinion.
So this sounds like the usual kind of youngish language problem, where maybe there isn't a library for everything yet, and there isn't documentation for everything yet.
Yeah, for sure. But also, I mean, it's not like Zig has invented systems programming. So it would be nice, right, if there was some good piece of, like, a good book that taught you the core principles without too much fuss. And in fact, there are plenty of books that try to teach you these things. It's just that in my experience, most of those that I've seen, they tend to conflate C-specific stuff with the OS. So, for example, you have this book that is trying to teach you systems programming, and it starts by telling you about how the C compilation model works and how that intertwines with, like, how libraries are, certain files are, like, laid out in your system. And this is all real and concrete, and it was especially real and concrete like 40 years ago. But those concepts, like in other things like macros and where things are usually in the C standard library, but those are things that are specific to C. So if you're not doing C, a lot of these things are not as timeless as the book thinks they are. While instead, stack versus heap, that one is much more timeless. So personally, I think that we're missing learning materials that can discern between really timeless systems programming concepts like stack versus heap versus C-isms that are not that relevant anymore.
Yeah. That's a sort of long life cycle, but not mathematically pure. You could almost say. Yeah. Okay, but so I would like to talk about how the C interrupt works, and maybe this is the way to do it. So if I'm actually looking to get the size of a terminal window, am I going to go looking for a sysup call and find I actually have to do it through an OSC library? And how's that going to play out when I actually start coding?
So, well, I guess it depends on the OS. Let's assume that the OS is Linux, okay? For simplicity. Okay. So if the OS is Linux, you're in luck, because in Linux, the syscalls are considered a public API of the OS. So you are not forced to use the C library of your OS. You can invoke the syscalls directly. And in the case of Zig, since we like doing things from scratch, you will find in the Zig standard library that we do implement the syscall, which I think it's IOCTL, the syscall that you can use to get that information from the OS. So in the case of Zig, in the case of Linux, that's how you find that out. But in other platforms, yes, you would have to use a clib, although we do have also bindings to the clib. So in practice, you wouldn't have to do everything yourself from scratch. When it comes to like these very common things, but let's imagine that instead you want to use like a C library.
Okay.
Let's imagine that you want to use, I don't know, SQLite. By the way, SQLite is a perfect example of a very popular library used, for example, by Go. There's a lot of Go projects that bundle SQLite, but SQLite is a C project. So that's one major use case of people using Zig to do cross-compilation when they also want to bundle SQLite. Anyway, you want to use SQLite. So at its baseline, here's what you want to do. You want to... The way this stuff works in C is that you have C files that contain implementations of things and have header files, which are like files with a .h extension. And those files contain definitions. So they do not contain the full implementation. They only contain like the signature of a function, for example.
Yeah, the original kind of API docs, right?
Exactly. The original API docs. Like they're what's it called? Is it called OpenAPI, I think? The thing that used to be called Swagger, it's basically like it's a system to document like RESTful APIs, right? That's kind of the idea, except systems programming. So the way this works is that then SQLite comes with a bunch of C files and one header file that you are supposed to include in your project to get access to the public API. With Zig, you can do that directly. So in Zig, you can import a C header file and it will work right away. Like you import that and you immediately get access to all the definitions in there.
Oh, interesting. Okay, so there's no kind of bridging file that you have to write.
Well, the bridging file, in a sense, gets auto-generated. That's the idea.
Right, okay.
So you don't see this. And actually, if you do want, you can do that manually. Like you can take the header file, translate it to C definitions, and in case there's like the need to tweak something manually, you can do that if you want. But the happy path, like the most common way you will want to do this, is just straight up import the header file and have Zig do that bridging internally.
Okay.
Then at that point, you can just straight up call all the SQLite functions that are defined in there. So you can just like go read the SQLite documentation. And they will tell you call, I'm making this up. I don't remember how to use SQLite, but there's going to be maybe SQLite
This isn't
init.
a test of the SQLite header API syntax, don't worry.
Okay. So there's going to be maybe some kind of SQLite init function. So you just call it and it works. There's also a couple other things that Zig does that help you with interoperability with C. So for example, C uses null-terminated strings a lot. So basically, there's when you want to give to a function a string, you give it a pointer to the beginning of the string, and the pointer doesn't carry information about the length. The length will be discovered by the function that you're calling by iterating through the string until it encounters a 0 character. Once it like a 0 byte. Once it finds a 0 byte, it knows that the string is over. Modern languages don't like to do that anymore. Modern languages very much prefer something else.
I'll tell you my age. I can remember when we didn't like to do it at the time.
So in Zig, for example, normally a string, it's not just a pointer to the beginning of some data with a null at the end. But in Zig, we use slices, which other languages sometimes call fat pointers. So what you call the pointer is a pointer, but also a length. So you have both informations. And to be fair, sometimes in C, you also have APIs that want a length. They don't want to discover a null byte at some point, but they want you to pass in a length. But those have have always to be two separate arguments, two separate values that you need to move around in parallel. Anyway, so how does Zig help with C interoperability? Well, string literals in Zig are null terminated. So in basically, when you write, hello world, and you want to use that string literal in Zig, that's going to be a pointer plus a length. I don't know how long hello world is. 10 characters, 9 characters, whatever.
Depends whether you include the traditional exclamation mark at the end.
Okay. Yeah, anyway. So you do have this information, but there's also going to be a null byte past the end of the string. So you can take a Zig string literal and pass it to C transparently. No need to do anything else. And it's always going to work. And more in general, Zig does have a bunch of functions in the standard library that allow you to deal with null terminated strings, which are not the preferred type of string in Zig. Like, you don't treat strings as null terminated normally. But null terminated strings are a reality not only because of C interoperability, like in terms of SQLite, but also because of C interoperability with the OS. Like OS APIs, the libc, that's C, but also the syscalls oftentimes inherit some C-isms, some ways of communicating data that are like mirroring what C does.
Yeah, unsurprisingly. Right.
Unsurprisingly.
Often the OS is written in C. So.
Exactly, because the OS is written in C, because that's maybe how people used to do things at the time. And so these things are still there.
Yeah.
Yeah. And okay, so to conclude, you have string literals. You have a lot of other operators in Zig that you can also use with C functions very easily, kind of transparently. But just to name one that I think it's really cool, you can use defer. So defer is almost the same concept as goes defer. There's some minor differences, but the idea is that basically, if you want to free a resource when exiting the function, instead of making sure that you call free or file close, for example, whatever resource release function you need to call, instead of making sure that you copy paste that call at every exit point of your function, what you can do is on one line, you open a file, and on the line below, you defer close it.
Oh, okay.
Yeah. So you have basically cleanup that you can put immediately after the creation of the resource. And whenever you leave that scope, no matter how you leave it, whenever you leave that scope, that function will be called.
Yeah, because it's always deeply dissatisfying that you have to remember to stick the close call or the free up call at the end, and it just screams this is going to get forgotten one day, right?
Yeah, absolutely. Yeah. So defer saves you from having to be too careful about branching paths in your function. And if you look at it from maybe it's not as handy as what C++ can do with RAI, with destructors that run automatically. You don't even have to write defer. Mm-hmm. But C++ destructors only work with C++. Defer in Zig also can be called on C functions. It's completely transparent. So there's this funny end result where basically Zig, in a sense, is better at using C libraries than C. Because the same cleanup routine in C would require you maybe to even use goto. It's not uncommon for people to use goto and have a label, a section of the function with all the cleanup functions, but it gets really messy. I don't think I am able to fully convey how messy cleanup can get in C because it doesn't have defer.
I can believe. Yeah, absolutely. That's interesting. Still being in C, but building on it with new syntax. I have to ask, before we leave this particular thread, what about pointers? Does pointer arithmetic come into Zig?
Pointer arithmetic can come into Zig. By the way, that's a great point. I was forgetting. That's another great improvement over C that also helps beautifully with interoperability. So you can do pointer arithmetic in Zig if you want to, because that's what the machine allows you to do. And maybe occasionally some OS API will require you to do so. Mm. But in general, you do not do pointer arithmetic in Zig. And specifically in Zig, you cannot do, so in the type system, you are not allowed to do arithmetic on pointers. What you have to do is take your pointer, convert it to an integer, which is not like an operation that does anything at runtime. It's just like a type system thing. Like you have to be explicit about taking a pointer, interpreting it as a number, apply the math to the number, and then convert it back to a pointer. So you can do it if you want, or if you need. Probably if you need. You shouldn't want. But the language is not going to make it easy or like very comfortable to you. There's a little bit of friction introduced there. And on the flip side, it helps identify very quickly where these kind of shenanigans are happening.
Right. So it's mainly there for the sake of C interop rather than writing Zig day to day.
Exactly. And I mean, we say C interop, but I don't know. There might be other things out there. Like I'm thinking of firmwares, like you're programming a tiny embedded device and you need something like this because of the very low level stuff that you're doing, which is not really necessarily specific to C anymore, but it's like super low level bit fiddling. Maybe at that point you need something like this. But otherwise you normally don't. And still related to pointers, there's another crucial thing. Pointers in C are very underspecified in the sense that you see a char star. So you know it's a pointer. And when you dereference it, you get a character. But then the question is, can that pointer be null or not? You don't know. Maybe documentation tells you, but you're not sure normally. The second question is, okay, I'm getting a character at the end of this pointer, assuming it's not null. Now, is there going to be just one character on the other side, or is this like a string? Is this like expected to have another character afterwards and another one afterwards until I encounter a null? Is there going to be a null, or am I supposed to know how many items to get because of another variable? This is not encoded in the type system at all. In Zig, all of these are different type of pointers. So if a pointer can be null, it's an optional pointer. So we do the thing that all modern languages are doing, where you have like the concept of optional, and then you need to unwrap the optional. And we use that to represent null pointers. But then we have types so you have normal Zig slices, which are a pointer and a length. But then you have a C-style pointer that can be, that's going to be a pointer either to one item, one specific item. So you're explicitly saying there's going to be one character, one char at the end, not many. Or there's syntax for saying, no, this is like a pointer to a unknown number of characters. So there's specific syntax and it's going to tell you, yes, this is a pointer to many items, but the pointer itself doesn't tell you how many. And then there's a pointer to an unknown number of characters with a null terminator at the end. And this is in the type system. So for example, if you by mistake think that you're trying to create a string off of another string, and so like you maybe take a tiny slice from the middle of the string and you try to pass it to another application, and you forget that API is expecting a null terminator at the end, which is not going to be there because you just split off like a tiny, like two characters from the middle of a string, right? So there's not going to be a null terminator on the other side. The Zig type system will tell you, it will give you a compile error because it will tell you, I'm expecting a null terminated string, but the operation that you, like the slicing operation that you did on the other string does not yield a null terminated string. So you will get a compile error right away instead of having your program read random garbage and maybe sometimes crash.
Yeah. That's one other question I have to ask you then, because I can see right now this appealing to people that need to use C, don't want to use C, got into Rust, didn't make friends with the borrow checker.
Yeah.
And now could find Zig being the ideal place if I want more type safety around C, particularly around strings.
Yeah.
What about memory management? Because that's the other big sticking point.
Right. Yeah. Agreed. So in general, if we want to talk about ergonomics, what I described earlier, like the first statement, that really helps a lot with memory management. Because you allocate a resource, defer, free it, and you're good to go. You need
so
to
there is
remember
an
to
explicit like malloc free call in Zigland.
Exactly.
Yeah.
And to be even more concrete about this, Zig does not have a global allocator. So in C, you have malloc. And malloc is like the allocator. And maybe different projects use a different implementation of malloc. There's like a few competing implementations. But in Zig libraries, there's this idea that in C libraries, there's this idea that you have malloc coming from the ecosystem that allows you to allocate memory. In Zig, allocators are always passed around explicitly. So if a function wants to allocate, it needs to accept an allocator as input.
Interesting.
Yeah. So this makes it more easy, dramatically more easy to audit what it is that's allocating memory or not. If a function doesn't accept an allocator, or a data structure that bundles the allocator in it. Like it's also like, for example, we have array list, which would be like the equivalent of a C++ vector. So like it's a growable array.
Right.
When you make an array list, you give to it an allocator, and then when you pass around the array list will be able to allocate because it bundles a reference to the allocator inside of it. That's for convenience. But in general, you can very quickly audit if a function can allocate or not.
Does that help you audit if a function is forgetting to deallocate?
That by itself, no. What it helps is that doing that is that what we call the general purpose allocator, the main allocator implementation that you find inside of Zig in the standard library, that allocator in debug mode has leak detection. So you cannot check statically if all allocations are freed. Or rather, you can't unless you're willing to become Rust. Rust can. With all the limits. They also have limits on the type of like memory management strategies that the borrow checker can understand. But they can. We can't. But we can instrument the default allocator with checks for leaks in the bug builds. So when you run your tests, basically, the allocator will fail the test if at the end of it you have like still memory allocated.
Okay, and that's default built-in part of the test suite. You don't have to specifically instrument.
Exactly. You don't have to do anything.
Oh, that's nice. That's nice, actually. Yeah.
There's another angle to this also, which is that it is correct for programs to want to leak memory occasionally. In this sense, I'll use the Z compiler itself as an example. So the Z compiler, when built in debug mode, will make sure to free everything. When built in release mode, it will not free once it's about to leave. It will not free memory once it's about to leave, to close, because the OS will clean up that memory anyway. And there's no point in freeing every single item that you've allocated if your program is about to exit. Like, making sure to free tiny things makes perfect sense when your program is going to use a ton of memory or it's going to be super long-lived. Like, otherwise, it's going to consume more and more memory over time until it eats all the available memory and everything explodes.
Yeah.
But for, like, let's say one-shot programs, kind of like a compiler is, like you run the utility, it runs to the end, and then it closes. Cleaning stuff up at the end is just wasted time. So have you ever used like Visual Studio?
Not for so long. I can't believe. Yeah.
Thankfully, I haven't had to use it in a while now, but a few years ago, like 7 years ago or something, I had to use it consistently. And it drives me nuts that when you close it, not only it takes forever to load, that is already not okay. But when you close it, it takes forever to close. Why? Why is it taking forever to close? Because as it's closing, it's trying to free and run the destructors of every single component and subcomponent and sub-subcomponent.
I have a vague memory of doing this with Eclipse and just getting into the habit of force quitting because who cares?
Exactly. Yeah. And Eclipse is another, in Java, I think it's another language that has destructors and so kind of makes people want to use them a lot. But then there's moments where you actually really, in terms of like functionality that you're offering to the user, you don't want to do it. Like you just want to close it right away.
Yeah.
So long story short, I made this point because in reality, it is a legitimate behavior to have the program in specific circumstances leak memory, if you think about it. Because like for real, like the user experience would be generally significantly improved in both Eclipse and Visual Studio if the thing just exited right away. Of course, you do want to have a toggle, like a flag, that makes sure you free all the memory cleanly so that you can guarantee that you do not have unwanted leaks. Like Visual Studio, for example, is a long-running program in Eclipse.
Yeah.
So they should not be leaking memory in the normal operations. So it's not.
Yeah.
So you still want to be able to test for that.
There are like there are at least two memory management strategies. One is be very careful about what you're using because it's a limited resource.
Yeah.
But for the long run, whatever memory you're using at the end, you can just drop on the floor, right?
Exactly.
Yeah, that makes perfect sense. There's one other big thing that you've talked about a little bit, but I'm tempted to run over our usual time slot because I'm fascinated by this.
Go for it. I'm not in a rush, for sure.
Good. Okay, so comp time. You talked a bit about that. And as an old Lisp programmer, this is a concept that makes sense to me, but I think it's never really gone mainstream. Yeah. So why don't we talk a bit about the separation between runtime programs and compile time programs?
Sure. So let me tell you about how Zig does this more specifically. So comp time in Zig is interesting because Zig as a language doesn't have runtime type information. So for example, in JavaScript, Python, also in Go, you can ask questions to the program running at runtime about its types. C programs, on the other hand, don't have a runtime and they don't have runtime type information. Usually, it's not always the case, but usually runtime type information tends to go hand in hand with an actual runtime of the language. So for example, in Python, you can create new types at runtime. You can do introspection. And so having a runtime that can yield those dynamic properties to you usually benefits from having runtime type information. C doesn't have those facilities because like a struct in C at the end of the day boils down to offsets in memory. The struct is, 16 bytes long and 8 bytes in, and like the first, it contains two fields. The first field is at offset 0 and the other one is at offset 8. And that's the end of it. So everything else has disappeared. But it is useful to be able to inspect types and reason about types, at least statically. So that's what Zig does. Zig does not give you runtime type information, but it does give you comp time type information. So you're not able to create new types at runtime, but you are able to create new types at compile time by reasoning on other types. And the way you reason on other types, and by the way, this is also what generic does in other languages. It's just that this is usually done with, in other imperative languages, this is usually done with a funky declarative syntax and a bunch of diamond brackets where you use diamond brackets to denote like the generic type and then to put constraints on it using like some kind of declarative syntax. Like I want type T to be, to conform to interface A or interface B, etc.
Okay, so are you saying you're using comp time to do things like I want a list of A's, but now I need to pin it down to be a list of 8-bit integers?
Yeah.
Yeah, okay.
Because the idea is that you are creating a new type by referring to another existing type. And the way you do this in Zig is not via this custom syntax, but by using normal Zig syntax. So literally, a list, for example, let's say you want to make a generic list and you want then to be able to make a list of integers, a list of characters, whatever. The way you implement this in Zig is that you create a function called list that accepts a type as input which has to be marked as a com time parameter. So like the signature would literally read fn list, open parentheses, com time t colon type. So it's a com time parameter named t of type. You have to pass in a type. And so that could be like integer or whatever. And then this function returns another type. And in the function body, you create a struct definition. You return a struct definition that defines the payload field, like a struct probably, that has the payload field of type t, what you passed in, which is kind of like generics work. But it's normal procedural Zig code that gets executed compile time. So, for example, you could create like let's say you're making a simple array, but the length of that array you want to be the result of other reasoning. You could create a Fibonacci function, run it at com time, and say that your array is long the 10th Fibonacci number, which I don't know how much it is, but it's not going to be 10. It's going to be a bigger number. Yeah. Right. So you can run normal Zig code. It's going to be interpreted by the compiler while compiling. And usually you do have some of that in other languages. It's just not fully general purpose. They give you restricted language to specify properties and they have their own special rules. In Zig, it's just you run the Zig code. And the compiler has like a concept of a execution quota. So that, like, for example, if you make a mistake and you try to make you make an array that is the 1000 Fibonacci number, but your Fibonacci implementation is very bad. The compiler, after a while, is going to tell you, I executed like 10,000 loops, and since we couldn't come to a conclusion, I gave up. And if you really think this is not like an infinite loop, then you can pull up that number, like the number of executions before giving up, and we're going to try again. But so that way, basically, the compiler is how it deals with infinite loops and undecidable stuff.
Yeah, so you're protecting against people accidentally making compile time infinitely long.
Exactly.
Yeah. And Alan Turing has opinions on why you can't automate that.
Yeah, exactly. So, and you know what? In our case, I think it's fine in practice to solve the indecisibility problem by just giving up, because ultimately, like, you're trying to compile a program and you're not willing to sit there forever or arbitrarily long to have it compile. So
yeah. Okay, so this raises two natural questions. And the first has got to be, what's that like as a programmer? Because most of us are used to using like diamond brackets for generics. Do you prefer the Zig way? Does it feel natural once you get used to it?
I think it feels insanely natural. Like you mentioned earlier, Lisp. To me, by the way, I also love Lisp. I've never used Lisp professionally, but like in university, definitely one of my favorite subjects. And I also loved writing macros in Lisp. And it feels like writing macros in Lisp. Or actually, I would say it's even better than writing macros in Lisp. Yeah, the spicy opinion. Well, so what I think happens with Lisp is that people say macros in Lisp are nice because Lisp is an homo-iconic language. So the language itself is the data structure that represents it. It's the list. It's the symbolic expression that represents it, which is fair. But I do think that the actual truth is that by having the program be a data structure, you are naturally, the language is steering you naturally towards treating the program as a data structure instead of it being a textual transformation. And in fact, you can write macros in Lisp that don't generalize really well, that like make assumptions about a specific like argument being or not being a list, or being or not being quoted, for example. In Zig, you are literally comp time is more limited than what you can do with Lisp macros, just to be clear. And that's also kind of by design. It's kind of like of a 80-20 thing. Like it gives you 80% of the power, but it saves you from the 20% of really cursed stuff that people will want to do all the time. Or rather, with 20% of the complexity, which does save you from cursed stuff.
Yeah.
in Zig, what you do is like when you look at the type, you literally call a function that, like, you call @type_info, and you pass in a struct. So let's say that you made a struct named person, and person has age and name. And then you call type_info on person, and what you get back is a data structure that contains, like, it's another struct that contains all the info about that type. Among other things, it will contain like an array that contains the two fields with information about how the field is called, what's the type, etc., etc. And so your metaprogramming is always going to look at the program as data and never as syntax. And I think that's the key that makes
Right.
comp time weirdly natural.
Okay, yeah. Yeah, it does remind me. I mean, the frustration with Lisp macros was always that they were untyped and you could really cause things to explode in an even more spectacular way than normal Lisp.
Absolutely.
But the nice thing was that there was absolutely no difference between writing programs that worked compile time and runtime, because it was the same tools, same language, same everything.
Exactly. And it's the same for Zig. Because you do use the same syntax. I have an example on a blog post that I wrote trying to introduce people to the concept of comp time. And my favorite example in there is this idea that, which is actually taken from real life experience. I was writing a Redis client for Zig. And in Redis, you have commands, like the query language of Redis makes you write commands that are case insensitive. So if you write it uppercase or lowercase, it doesn't matter. So at some point in my client, I wanted to recognize some of those commands. So I wanted to check for equality between two strings. And my idea was, well, to very slightly improve the performance of the comparison function, if I know that the constant string, like the string literal that I hard code in my program, that I used to check the user provided string against, if I know that that one is always going to be uppercase, I can simplify the comparison code ever so slightly. I can just remove one branch from the comparison. But now I want to enforce that when you call my equal function, you always pass in the first argument. The argument that you pass in, the first argument that you're passing, is always going to be uppercase.
Right. Now, so you want some compile time code to check those strings are correctly written.
Exactly. Now, imagine trying to do that with diamond brackets stuff. I have no idea if you can actually even pull it off. Here's what you do in Zig. In Zig, in the function body, you open a comp time block. Well, first of all, you have to mark the first argument as always being available at comp time. So people will be forced to give you, it doesn't have to be a string literal directly. It can be like a variable name. But ultimately, the value contained in that variable needs to be resolvable at comp time. It doesn't need to depend on weird stuff like the network.
Yeah.
So you open a comp time block, and in there, you have a for loop that loops over the string and checks that each character is in the correct range. That's it. That's all you do. Nothing weird. You just use the language to check the string character by character. And if you find a character that is not in your expected range, so in my case, it was between uppercase A and uppercase Z, what you do is that you emit a compile error. And you can emit a compile error that says, well, you are supposed to give me a uppercase string, and you didn't give me an uppercase string because this character is lowercase. You can even be precise and print the string and point at the specific character if you want. You can craft the message whichever way you want. And that becomes the compile error. And so now users of your API, not only the constraint is enforced. So if they give you a bad string, they will get a compile error. But the compile error is also going to be designed by you. So people will get a nice compile error from the compiler that will tell them you're supposed to pass an uppercase string, but you didn't.
Nice. Yeah, so you can start doing bespoke compiler extensions.
Exactly.
And you don't have to learn a new language to do it.
Nope.
That's pretty sweet. Okay, that gives me a good sense of the footprint of the language. So there's one other big topic I think we should talk about, which is, I thought it was really interesting the way that the Zig project is funded, right? Because every language, particularly in every open source project, has a problem with getting enough work done, because you've got to give up your day job if you really want a language to take off.
Yeah.
And your approach, Zig's approach to funding, is fairly novel. Tell me about that.
So Zig is a 501c3 nonprofit foundation, US nonprofit foundation. Like 501c3 is a thing in the US legal system.
It's been kind of set up like a charity.
Yeah, it's exactly what we normally would consider a charity. So it's tax exempt, and you cannot pay dividends. So all the money that goes into the organization has to be used to pursue your mission. So basically, you have to use that money to run the company. You can take it out and buy a yacht with it or whatever, a mansion. Zig is not the only language that has this legal structure. Python, I think, is also another 501c3, but not all languages are that. Some other languages are a different type of, it's still considered non-profit, but it's a different type of organization, and which does have to pay taxes. This is what is usually it's 501c6. Like it might seem that there's not much of a difference between 3 and 6, especially because it's place where we normally in like semantic versioning, we would have like the batch number. So you think, oh, C6, C3, whatever. It's like they fixed the bug in there. No, there's a huge difference.
We're not always consistent with version numbers, but my God, lawyers, they can really change the rules between versions.
So Zig specifically lives mainly off of donations. So most of our income comes from people donating money to the foundation so that we can move forward with the development of Zig. Some money also comes from other things. So it's mainly donations from individuals. We do have also a good number of donations from companies, but I think in terms of like if we were to do a pie chart and plot them both, they would, I think, roughly be balanced. So we do try actively to keep a balance between our sources of income because we don't want to get in a situation where like one entity or like a very small number of individuals end up having control basically over the foundation. Maybe not directly, right? Not legally, but if they control the money flow, then ultimately they do control the destiny of the organization.
Sadly, yes.
Yeah. And we do want to be able to say no to people. We do have support contracts, or rather we have one with Uber, because Uber is using Zig to cross-compile. They are cross-compiling, I think, as of today, all their backend services that require cross-compilation. Because of ARM servers mainly. So like they wanted a while ago to be able to have ARM servers and not just Intel, well, x86 64. And so they use Zig, and now they did the work to actually make sure that all their C and C++ stuff cross-compiles correctly. And yeah, so they have a support contract with us. But then again, it's not a huge chunk of our income. And that is mainly it when it comes from income. So related to this, also, we kind of want to be independent. And we're very serious about this. Like we used to joke that because, you know, people sometimes say, oh, if you want your language to succeed, like you cannot make a successful language unless you are supported by a big tech company. And we kind of beg to differ, but also our standard offer is how much money whatever big tech company wants to give us in exchange for 0% of the foundation and 0 seats in the board of directors. But they do get Zig in the end. So they do get something in the end.
Yeah. There is some quid pro quo, but no power.
No power, no control at all. 0, absolute 0. And because we really want to make sure that we, like the Zig is a BDFL run project. So also compared to other languages, we basically ultimately have Andrew, who is the creator, who acts as like the ultimate decision maker. It's not only him. There's a core team. There's people. There's a process which is also very public. Like you can read proposals to change the language on the GitHub, and discussion happens in public, and actually anybody can chime in. But for example, it's not a democratic process. Like if a feature proposal has a huge number of upvotes, that counts 0 towards the decision of whether to include that feature or not in Zig.
Right.
Yeah.
That has some downsides, but usually has great upsides for design consistency.
Absolutely.
Yeah.
And it's absolutely, in my opinion, fundamental if you want to have your language stay small, if you don't want it to eventually devolve into a kitchen sink.
Yeah, that's true.
And there was a talk by the creator of the Elm programming language recently that I think dove into this general concept, I think, in a very nice way. Basically, I'm paraphrasing and I'm going to oversimplify. The talk is titled The Economics of Programming Languages, I think. It's from Strangeloop. And, it was given at Strangeloop. I highly recommend it. But the bit that I'm interested about was said something along the lines of languages that are like 501c6s, like more corporate languages that end up having like a bunch of organizations come together into a like kind of consortium or like a trade association. They basically look at the language as a marketplace. They look at the shared infrastructure and all the commerce, all the business that this thing can support. So, which is reasonable, right? You look at a language like, I don't know, C# or Java, and those languages do enable a certain type of commerce. So from their perspective, they want the commerce to be as much as possible. They want to give the best market to their organization members. And so if an organization member wants something because it helps them do their business, you have a strong incentive to say yes. And whoever doesn't need that feature, they cannot use it. They can disable it. They don't have to use it, right? So there's no point in saying no to people if your goal is to have the biggest possible market. But as technologists, we know that, there's some downsides from that, right? Once your language becomes a kitchen sink, then it's not good over time. So there's huge value in keeping your thing small and consistent. And I think that's what you get by choosing 501c3 over 501c6, or rather not going down the path of making your organization like a trades association.
Yeah. It's interesting, the thought that one decision, how you're structured as a company or as a financial organization, will influence how you're designed as a language.
It has huge influence. Programmers don't want to think about this stuff. They like to think, I just want to focus on the code, which is, it's a sentiment that I can understand. Frankly, I would like to only focus on the code. But the hard lesson that I learned is that to have the best technology, you have to get right the business side. Like the business side comes first. Every time you make a mistake there, the technology will suffer.
It will, in the long run, it really matters. In the short term, it doesn't. The long run, it has a huge effect. Yeah, that's true. Okay, well, I'm very glad we diverted into comp time, but we should probably wrap up and let the listeners go to runtime. How's that for a segue? So, if someone wants to get started with Zig, I know you have LSP support, you have a VS Code plugin, you've got all the quality of life things for a new beginner, but where should they start learning?
My recommendation would be go to the official website, ziglang.org, and there's a Learn section. The Learn section has like a guide on how to download Zig, install it, and it also links you to some learning resources. Personally, among those, the three main ones that I would suggest is, as a starting point, the language reference, the documentation that tells you about the language, not the standard library. That one teaches you specifically about like syntax of the language, and it's one page. It's one long page. Like it's not an A4 or US letter page, but it's like just one page is not huge. And you don't have to read it all precisely. You can scroll through it. But that one gives you baseline understanding of Zig.
Right.
Then from there, I would suggest, if you don't have like experience with lower level programming and you want like a very smooth learning curve, Ziglings is the best starting point, in my opinion. So Ziglings is like a community project where basically you clone the repo and you get a collection of very tiny programs that don't compile or that don't behave correctly.
Oh, okay.
Yeah, and the comments tell you how to fix them. So you go one by one, and the comment will, oh, this program is supposed to print hello world, but it doesn't. Fix it. And that's going to be super simple, right? You're going to just fix the string literal. But then going forward, the exercises will become very smoothly, but they will become harder, and they will require you to understand more of the syntax.
You know, I think that's how I learned Clojure. They had a similar thing called, I think, the Clojure koans, as like a series of small failing programs that you have to fix, and you gradually learn the whole language. It's a lovely way to learn a new language.
Yeah, Ziglings is very, very, very popular. I would say it's probably the most popular piece of educational content in the Zig ecosystem. And the name Ziglings is also inspired by Rustlings, because Rust also has it. The same thing, and they call it Rustling.
Right. Nice. I will link to both of those in the show notes. But for now, Loris, thank you very much for joining us. It's a fascinating language with almost more scope than C, which I can't believe.
It has pretty much all the scope of C. It tries to fix all the things that C, for some reason, never wanted to fix. Like, think about it. Why is Zig able to cross-compile C, and a C compiler is not going to be able to give you that out of the box? Like, we didn't get into this, but like you get the Zig compiler and you write hello world in C, and you can compile it from Linux to Windows. Try to do the same with Clang. It's not going to work.
I'm not even going to try.
Yeah, but it's insane. So yeah, the scope is all of C, all of the things that C should have done that it didn't do, plus a little bit extra.
Nice. That's enough to keep us busy for a while.
Yeah.
Loris, thank you very much for joining us.
Thank you.
Thank you, Loris. Since we recorded that conversation, I have been playing around with the Ziglings tutorial he mentioned, and yeah, I can confirm it's a nice way to learn. I'm also planning to find time to pull out my old Arduino microcontrollers, because I've dabbled with kind of embedded hardware in the past. I've never really been happy writing C. I've loved using Rust, but it's been a fight to get things to compile onto the embedded hardware. So hopefully, Zig is going to finally make me happy when I'm tinkering with soldering irons and wires and LEDs and stuff. In the meantime, I leave you with links to everything we've discussed. They're all in the show notes. There is a wealth of information out there about Zig, how to learn it, what it does, extra features we didn't get a chance to cover. And I'll leave you with a fun Easter egg. If you install Zig and type Zig Zen, it will tell you why it exists. I'll let you go and discover that. Before you go, please do take the time to give us a like or a share or a rate or a review. It is the easiest way to let us know which topics you find most interesting, so we can do more episodes on those kinds of topics. And if you haven't already, click subscribe or follow to catch future episodes. And until the next episode, I've been your host, Chris Jenkins. This has been Developer Voices with Loris Cro. Thanks for listening.